Hello and welcome to this online College of Coding video tutorial series. This is the 5th video in the series of Breaky blocks intermediate in GameMaker. In this video we're going to make the game even more interesting by adding the bricks. Before starting this video, it's recommended you've seen the previous videos in the series, as well as the introduction to GameMaker and intermediate programming concept videos. Let's get started. Our bricks are going to be spawning into random patterns within the level. This might sound complex, but we can break the algorithm down into 3 separate objects. Firstly, let's create the brick. Click the Create Sprite button and name it SPR_brick. Click the Load Sprite button, hold Control and choose all of the brick sprites. Then click Open. Click the Center button to center our sprite, and we need to tick Precise Collision Checking. That's all we need to do for the brick sprite. Press OK to close it and click the Create an Object button to create a new object. Give it the name obj_brick and assign it the brick sprite. That's all for now for the brick. The second component of the brick spawning will be an object that creates a single row of bricks. For this, we don't need a sprite, we can just create the object straight away. Let's name it obj_brickgroup. By capitalizing both the B and the G, you can tell where the 2 words start. This is called camel case. Let's use the Add Event button and give our brick group a create event. To make this object do what we need, it's going to need to have some code run. So drag in the execute code action and let's get typing. We're creating an algorithm that will spawn a row of bricks in place of this brick group object. For this, we need to know the width of the brick sprite and how many bricks will fit in a row. To get the sprite width, we need to provide an asset index, which is a number corresponding to the sprite within the resource tree. Just make sure the name here matches the sprite name. The number of bricks in a row is the distance between the 2 walls divided by the width of the brick sprite. We use the floor function to make sure we don't get any half bricks by rounding the number down. The for loop will run once to create each brick, calculating their X position that will place the brick in the correct place. Then, after the bricks have been spawned, we destroy the brick group object because we no longer need it in the room. Now we can close the code editor and close the brick group object. The controller object will be the object that manages the spawning of the brick groups. So to create the controller, we first need to create an object and then call it obj_controller. Just like our brick groups, the controller object doesn't need a sprite, so we can just click the Add Event button and go straight to adding a create event. Drag in an execute code action from the Control tab, and when the editor pops up, let's start typing some code. The variables we're creating in the controller are going to store some information that it needs to know about the bricks, such as the number of rows that have been spawned, the current height of the bricks in the room, the maximum height of the bricks in the room, and the actual height in pixels of a brick. All of these variables work together to control the spawning of the bricks, making sure they spawn up to the top of the room and stop there, and also to stop the bricks spawning on top of each other. Let's close the code editor. We're done in the create event. We need to add another event to our controller, a step event, so click the Add Event button and then choose a step event. Again, we're going to drag in an execute code action and type in the following code. Each game step, the controller records its own Y position. It also calculates the position of the top row of bricks and stores that number in the brick row variable. If there is space for another row of bricks above the top row, then we spawn another row and add 1 to the spawned rows variable. The spawned rows variable helps calculate the top row's value. For now, that's our controller done, so click OK to close it. So that we can test out the functionality we've just added to our controller, we need to place a controller object in the room. So open up the room, go to the Objects tab, and from the drop down on the left, choose the controller object. Then place one in the middle of the room somewhere. Because we're only testing, it doesn't matter exactly where you place it. Now press OK to close the room and let's test the game. You'll notice that all the bricks change color pretty quickly. To fix this, we need to freeze their sprite animation. Of course, we don't want every brick to look the same, so we're then going to have to assign them a random sprite number. So let's open up the brick object and click Add Event and add a create event. Drag an execute code action into the actions list and add the following code. By setting the image speed to 0, it stops our bricks from animating. And by setting their image index to a random number, we set their sprite to be a random sprite. The iRandom range function will generate a random integer within the range we've supplied it, so 0 to 4, which corresponds to the number of images within the brick sprite. Close the code editor and close the brick. Let's test our game again. The brick sprites aren't changing anymore, and they've all got random sprites. Cool. Now let's add another quick change to our brick spawning. Open the brick group object and go to the execute code action in the create event. Inside the for loop, we're going to add an if statement. To add a bit of randomness to the brick spawning, we've added an if statement that will stop 3 out of 10 bricks from spawning. This is done by using the iRandom function to generate a random number between 0 and 10, similar to the iRandom range. If that number is bigger than 3, then a brick will be spawned. Close the code editor and now close the brick group and test the game again. As you can see now, some of the bricks aren't spawning, and that's what's creating our holes. Now we can move on to adding collisions between the ball and the brick. Open up the ball object and add a new event, a collision event with the brick. From the main 1 section, drag in a destroy instance action and set it to apply to the other. The other object in the collision, the brick, will be the one that gets destroyed. From the move tab, drag in a bounce action and set it to bounce precisely against all objects. Really, that should be all it takes. So close the ball and let's test it out. Okay, so our bricks are being destroyed by the ball, but we told the ball to bounce and that's not happening. Let's go back into the ball object and have a look at our actions. It's important to remember that the actions we place at the top of the action list are going to happen before the actions at the bottom of the list. So if we destroy the brick before we bounce off it, there's no brick left to bounce off by the time that action gets run. The simple fix for this is to just drag the bounce action above the destroy action and everything will work fine. It's important to remember that sometimes in programming the order of operations really does matter. Excellent, the ball's bouncing around just as it should be. And with that now working, we've reached the end of the tutorial. Well done, you've done an awesome job making it this far through the series. In the next video, part 6, we're adding a death wall to our game that's going to destroy the ball if you don't get to it with the paddle. So tune in next time, I'll see you then. Keep up the good work.